Hey guys, it's Mr. Wolf. If you could, please turn your packet to page 6 of your new Unit 2 packet. We're going to be working on a new unit now, but before we do that, I'm going to reference Unit 1 really quick. We were focusing on in Unit 1 what was happening to an object when the net force was 0. So when our net force was 0, our object was moving at a constant speed, whether that object was at rest or whether the object was in motion. Now we're going to be looking at is what is happening to our object when our net force is no longer 0. It could be positive 1 newtons, it could be positive 1 million newtons, it could be negative 1 newtons, it could be negative 1 million newtons. The idea is that it's no longer 0, or net force is no longer 0. So when it's no longer 0, we're no longer going to be traveling at a constant speed, but rather we're going to be having changing motion. So really quick, I'm going to review the targets that we're going to be going over in this PowerPoint. So these are going to be targets 1, 2, and 3, and they're fairly familiar in terms of looking back at Unit 1, where we're still describing motion through words, we're still going to be using motion diagrams, and we're still going to be using our two different graphs, our distance versus time graph and our velocity versus time graph. The only difference now is that instead of just constant motion, we're going to be looking at changing motion as well. And so our big term for the unit is going to be acceleration, and we'll go more into that as we go through the PowerPoint. All right, so in class, when we rolled the ball down the ramp, we found a slope like this. And so this is different from what we've seen in the past. And what we used to see in Unit 1 when we measured that buggy is that it was moving at a constant speed. And so at any point in this slope, in this line, our slope was the same. So we were moving at a constant speed. This line, however, this new line is different. So if we were to take our pen tool and look at the steepness of the slope here, the steepness of the slope here, here, and here, right? We see that our slope is changing. We have a different slope. And remember, for our distance versus time graph, our slope is equal to our velocity. And so if our slope is changing here, that means also our velocity is changing. So this line right here is depicting an object that is changing its motion. And so our velocity is changing, but if hopefully I pointed out at the end of class today when we made our velocity versus time graph is that the points between this slope and this slope, although the slope was different, it was increasing by, let's say, 5 meters per second in this scenario, but also between this slope and this slope, the increase was also 5 meters per second. So we're seeing a fairly consistent increase in the slope per time interval. So what does this mean? Well, a way to kind of explore this is let's now look at a velocity versus time graph. All right, so this table right here is referencing what I was going over before, is that our velocity, that slope, was going up by a steady interval. In this case, 5 meters per second, 5 meters per second, every second. So in the past, when we worked with these velocity time graphs, our object was moving at a consistent speed, and this made sense because, let's say, it was moving at 30 meters per second at time 1, and if it was moving at a constant speed at 5 seconds later, it would still be moving at 30 meters per second. But now we're going to be looking at changing motion. And so looking at this new data from that graph we made with the bowling ball, I'm going to be looking at this table right here, is that for every second, our velocity increases by 5 meters per second. And if we go another second, our velocity also increases by 5 meters per second. So I'm going to draw a line to fit this change. So what we get is this straight line right here. And if you remember with the distance versus time graph, what we're really doing is we're looking at the change in distance over time. So this change in distance. And what we got was the slope, and the slope was equal to velocity. So now we're looking at a velocity versus time graph. And so what we're doing is we're looking at our change in velocity over time. And so this slope, just like our d versus t graph, is also going to mean something. So the slope is going to be your change in velocity over time. And what this is also known as is just acceleration. So the slope of our v versus t graph is going to equal our acceleration. And so acceleration is really just a change in velocity. So I know sometimes you guys might get the connotation of an object speeding up, but it could also be an object slowing down. And acceleration is just referring to that change in velocity. All right. So velocity and acceleration are both rates. So what I mean by that is, and I've kind of mentioned before, or in the previous slide, is that velocity is basically saying for every second, our position is going to be changing by a certain amount. So in this case, for every second, we are moving 2 meters. Our acceleration, again, is going to be a rate. It's going to say for every second, our velocity is changing. So this meters per second is also our velocity, is changing by some amount. So in this case, 5 meters per second per second. Now acceleration could also be written in meters per second squared. However, you could write it in both ways. However, I like this way just because it shows that acceleration is a rate. It's really just the rate of velocity changing over time. All right. So again, acceleration is the rate at which velocity is changing. It's a change in magnitude, and it's also a change in direction. So a change in magnitude and direction. Acceleration is then going to be a vector quantity. Right? And so this is going back to those units I was talking before. We could use meters per second squared or meters per second per second. They're really the same thing. Right? And so for the most part, that really concludes this video. But really quick, you may have kind of felt a little bit scattered in terms of going through the packet. So what you should have filled out was that d versus t graph on page 6. And then we went to the velocity versus time graph on page 7. Don't worry about the graphs at the bottom of page 7 and 6. But if you go to page 4 of your packet, you'll see the notes for acceleration there. These were the last part of the PowerPoint. And so our big takeaway from this PowerPoint, and really kind of for the unit, to start off with the unit, is that we are now looking at changing motion. And our way of describing how velocity changes is acceleration. All right, so thank you for watching. Also, really quick, do not worry about filling anything out for page 5 and target 2 for tomorrow for homework. We'll go over that in class, and I will see you guys tomorrow.